Hello everyone and welcome to another episode of Interstigation. In today's episode, I will go over 2021 MIMC and all of the problems from it. I am actually a problem writer of it, so I decided to make a video solution and a paper solution. If you don't understand, please write all your questions in the comment down below or in the discussion forum in the AOPS. So let's get started with number 1. Number 1 is relatively easy. We can just convert 1/2 to be 128. We can convert 1/2 to be 128 over 256 plus, that's 1 over 256. Remember 2 to the 8th is 256, and that is the inverse of that, which gives us the answer 256 under 129 over 256, which is the answer choice C. So let's proceed with number 2. We know that pi is around 3.14 and that negative 2 pi is around 6.28. Oh, negative 6.28. And that is definitely smaller than negative 6. And 3 pi is around 9, and that is 9.42, and that is greater than 9. So we can convert this equation, because we only want integer solutions, to negative 6 less or equal to x less or equal to 9. That will give us all of the solutions between negative 6 all the way to 0, 1, and all the way to 9. And that's 6, 1, and that's 9 solutions. And in total, we will have 17 solutions. And now we can go over number 3. And there exists an integer x such that the twice of the reciprocal of x. So let's write that down. Twice of the reciprocal. We can write that actually as 2 over x is 8 times the square of the reciprocal of x. So is, which is our equal sign, is 8 times the square of the reciprocal. So the reciprocal squared, and that we can actually write as x squared 8 over x squared. And cross multiply it, we can get 2x squared is equal to 8x. And that will result in x squared is equal to 4x, or x minus 4 is equal to 0. Now, realize that there are 2 solutions. One solution would be x equal to 0, and the second solution would be x equal to 4. However, 0 does not have a reciprocal, so only answer 4 would have a reciprocal, and 2 times 4 over 3 would result in 8 over 3, or answer choice B. Moving right on to number 4. In number 4, it asks for the area between the circumcircle and the incircle of the equilateral triangle with area of 4 square root of 3. First of all, we can calculate the side length of this equilateral triangle. Cannot draw it very well here, but you notice that this is an equilateral triangle. And if you don't know the area of the equilateral triangle, we can just calculate it out. We know that equilateral triangle, all 3 sides are equal, so that will be, if we set that 2x, and that will be x, as it will be a bisector, and that will be x square root of 3, and the area would be 2x, as it is a base, times x root 3 times 1/2 is equal to our 4 square root of 3. You can cancel these out and cancel these out, resulting x squared is equal to 4, or x is equal to 2. Notice that our side length is actually 2x, so our side length would instead be 4. And this side length will be 2. Now, let's draw an incircle and a circumcircle. Cannot draw it very well on a device, but you get the idea. And we know that our center would be on the centroid, and the centroid would divide the triangle's height into 2 and 1, or equilateral triangle's height, not necessarily any triangle's height. But if you don't know about that, we can prove it. So if we set this to be the big radius and this to be the small radius, and we know that this is 30 degrees because that is a bisector, and r squared minus r squared is equal to 2 squared. And that r, since it is a 30, 60, 90 triangle, would be equal to 2 over root 3. And this big R would be 2 times that. So that would be 4 over root 3. And the area of the incircle is equal to pi r squared. Let's just write that. Or equal to pi times 4 over 3. Or just 4 over 3 pi. And the area of the circumcircle is equal to pi r squared, or pi times 16 over 3, or 16 over 3 pi. And subtracting that, we will get 16 over 3 pi minus 4 over 3 pi, which is 12 over 3 pi, or 4 pi, giving us the answer choice B. So let's proceed with number 5. It states that Mr. James has 8 books on his shelf, which includes 3 math books, 4 English books, and a Spanish book. He wants to rearrange them so that all the math books are adjacent to each other and all the English books are adjacent as well. So we can think of this as, let's say there is a math box that contains all the math books, and an English box that contains all the English books, and also the Spanish book. Within the math box, there will be 3 math books, and they can arrange them however they want. So that will be 3 factorial, or 6 ways. Within English box, there will be 4 books. Therefore, it will be 4 factorial, or 26 ways to rearrange them. And the Spanish book would just be 1 factorial, which just is 1. We don't need to write that out necessarily. But we need to arrange math box, English box, and the Spanish box at the end. So think of this as 3 books, 3 items. So in total, there will be another 3 factorial 6 ways. Let's multiply these together. 6 times 24 times 6 times 1 if you want, but we don't need this. We can calculate this out to be 864 ways, but you don't actually need to do that. Examining the answer choices, this is the only one that does not end with a 0. And we know that there is nothing that has a factor of 5, so we know that this expression does not have a 0 at the end. So our answer will be C. So here's number 6. In number 6, it asks the denominator would be more than 1 element. So each element can be there or not, so resulting to the 7th, or 128 possibilities. However, there is an empty set, or a set containing only 1 element, 1 through all the way through 7. So we need to subtract 8 out of those. So the denominator would be 120. And the numerator has 2 requirements. The first requirement that has no 2 elements, that has GCD is larger than 1, and the second requirement would be the subset does not contain 1. So since it does not contain 1, our limit would be reduced to about 60, and a better way can be a complementary counting, and that is already on the solution. So I would do actually just list them out. But before we list them out, we want actually a pattern that we can list them out so that we don't miss any, we don't overcount any. So let's get started. The element that I think of can be 2 elements, the order 2 elements, 3 elements, 4 elements, 5 elements, 6 elements, because it does not contain 1, so it cannot have any of the 7 elements, or 1 element because it has more than 1 element. And let's get started by listing out the things that actually does violate the 2 elements that have GCD is larger than 1. So 2 of them can be 2, 4, it can be 2, 6, it can be 4, 6, and it can also be 3, 6. I think that's all of the ones that we don't want. So choose 2 elements from it. We can have, so from 7, choose 2. But we need to subtract the ones that we don't want. The ones that contains 1, so that's 6 of them. And the ones that contain these, so that's 4 of them. So that would be 7 times 6 over 2, that's 21, which would be 11 subsets. And with 3 elements, we can just list them out because there aren't as many. And for 3 elements, we can have, it starts with a 2, it can have 2, 3, it cannot have 4, it can have 5, 2, 3, it cannot have 6, so it can have 7, 2, it cannot have 4, so 5, it can have 7, or because it cannot have 6, so 2, 5, 7, 2, 6, nope. So that's all of them starting with 2. So 3 can have 3, 4, 5, 3, 4, 7, 3, 4, or 3, 5, 6. But we cannot have 6, so 3, 5, 7. And that's all we have for 3 and 4, 5, 6, that cannot happen. 4, 6, 7, it cannot happen. 4, 5, 7, yes. And starting with 5, that just cannot have any. Or, yes, 5, 6, 7. That will be 8 cases. That is 11 cases. And with 4 elements aboard, we can have, starting with 2, we can have 3, we can have 4, no, we cannot have 4, we can have 5, we have to have 7, that's 1, and starting with 2, we can not have any other ones. 3, starting with 3, we can have 4, we can have 5, we cannot have, so that's 3, 4, 5, 7, and starting from 3, 4, 5, 6, 7 does not work, and any other one starting from 3 does not work either. So let's proceed with 5 elements. Notice that if I have, so that is 5 elements. 5 elements would just be kicking out one of these from this 6 element set. We notice that if we want to kick out 2, then there will be these present. If we want to kick out 3, there will be these present. If we want to kick out 4, there will be these present. If we want to kick out 5, then all of these will be present. And if we want to kick out 6, then these would be present. So if we want to kick out 7, then all of these will be present. So we cannot really make any with the rest 5 elements or 6 elements. So let's just sum them up. That will be 19 plus 2, or 21 cases in total. And that 21 over 120, simplify that, divide both sides by 4. That will result in 2x plus y. So 2 times 7 plus 40, or the 54. For number 7, I have what is the sum of all possible values of x if they're both integers, and given this equation. Notice that it is integers instead of positive integers, because that will be very, very crucial at the end. So you can factor this equation using Simon's favorite factoring trick. If you don't know that trick, I can teach you right here. We'll go slowly, and if you already know this trick, you can skip this video. Skip to like 1 minute later. And notice that these have a common factor of x, so we can combine them. That will be x times y plus 2 plus 3y is equal to 2. We want to combine this as well so that we can kind of factor this, but we cannot do that unless that y has a plus 2 at the end. So we add that plus 2. So y plus 2 times 3 is equal plus x plus y plus 2 plus that is equal to 2. However, we add 6 on the left-hand side of the equation, so we have to add 6 on the right-hand side as well. That will be 8, and the left-hand side can be factored out as well. So x plus 3 times y plus 2 is equal to 8. And now, because all of these are integers, so we can say that both of these terms are integers. So that will be 1 times 8, or 2 times 4, or 4 times 2, because x plus 3 is equal to 2 is different from y plus 2 is equal to 2. So we need to consider both of these scenarios. Don't forget the negative ones. That's where the negative ones comes into play. So don't forget them, and make sure to have them in the back. And all of these can result in our some x values. So let's say that this would be x plus 3 and this would be y plus 2. And now we just want the x values. So that would be negative 2, that would be negative 1, that would be positive 1, that would be 5, that would be negative 4, that would be negative 5, that would be actually negative 7, and that would be negative 11. And we just need to sum them up now. And all of these sums would be negative 3, negative 2, that is positive 3, negative 1, negative 6, negative 13, and that would be negative 24, giving us the answer choice B. So in number 8, it wants us to find the sum of digits in this expression, this massive expression. Notice that every term in this expression is 10 to the something power. But it's not 0, 10 to the something power minus 1. So we might as well take advantage of that. That will give us 100 minus 1 plus 10,000 minus 1 plus, that's 6 zeros, that is a million, right? That's 6 zeros, a million times 1 minus 1, and then plus all the way to, that would be 200 nines. Notice that 200 nines correspond to 200 zeros instead of 200 digits, which you may think that would be 200 digits including 1, but it's actually excluding 1. 200 zeros minus 1. And we need to calculate the number of terms in this. So the first term starts with 2 nines, and the last term has 200 nines, and that would be 200 minus 2 over 2 plus 1. We can put that back in, so that would be just be 200 over 2, or 100 terms. So that would be, our sum would be 101010 all the way to 1010. No, now that notice that the last term would be 100, so there is extra 0 at the end. Do not forget that. And 100 terms, so it's minus 100 at the end. Therefore, we need to find the amount of ones in this expression. The amount of ones in this expression would just be the number of terms, because each term just contributes one, right? Now, that will be 100 ones. And if we subtract that 100 at the end, the final expression would be equal to 10000, and that will have 99 ones remaining. And the last 4 digits would be 0000. So x plus y would just be 99 plus 0, or just 99. In problem number 9, it looks confusing. It defines a function of this that such that this happens and asks the f that, which it is not a recursive function, so we can just plug that in, and that would just be f 21600. That would just be the floor function of square root of 201,600, which, to be honest, the f is useless, so we can just erase that. We want to find this value. And this value, given by the answer key, has two polarized answers, about 150 or about 450. So we can calculate 150 squared first. 15 squared would be 225, and add 2 zeros at the end. That is definitely way far away from our actual number that we want to calculate. So it must be around 450. That's squared, because 45 squared would be 202500. That will almost be there. And now there are two ways to calculate this, because 449 squared would be equal to 202500 minus 450 minus 449. Or you can just calculate it out with this. Right? Not so bad. 99, that's 81, that's 36, 44, 49, 36, that's 40, 49, 36, 16, 19, 16, 17, 1796, and just add all of these up together. So that would be 1, 0, that is 7, because that 6 plus 1 is equal to 7, and no, that would be 6, because that 9 plus 1 is 0, and then yes, and that would be 11, that's 21, and that is 8, that's 20, 201, 601. That is 1 away from what we want, so our answer must be 448. Now let's try with this method. This method would give us that 202050 minus 449, and you can make one of these charts, because that may be more accurate than what you actually calculate with, and that will return the same answer. And so our answer would be D. Moving right along with number 10. Number 10, it asks what is the multiple of which of these numbers. So by Wilson's theorem, or if you don't know it, I will put a wiki's page of Wilson's theorem down in the description. You can look at it. But with Wilson's theorem, we can know that 100 factorial is -1 to the 9th plus 506 mod 101. And we know that -1 to the 9th would be -1, and the mod number would not change. And plus 506 mod 101, which is just 1, meaning that would be 0 mod 101. Therefore, that expression is a multiple of this. So the wording for this problem is a little bit weird, and it basically states that there is a 30, 60, 90 triangle with with angles called ABC, and it has a longer leg is length 8. So let's label that BC. But the hypotenuse is AC, so we have to put C here, B here, and A here, and that will be 8. That's 90 degrees. That's 60 degrees. And they intersects the side DB at E. So there is another overlapping equilateral triangle with basically sides at the same, right? Basically, it has to be either like this or this, but it says it's overlapping, so the sides will be like this. And that is an equilateral triangle. And the hypotenuse is AC intersects that DB at E. And the length of CE can be expressed as that. So we want to know the length of CE. And a direct way of doing this is to calculate this, but maybe you don't know anything about this. But we know that this is 60 degrees, and this is 60 degrees, and this is 30 degrees. So that must be a height, because that would be 30, 60, 90 degrees as well. And using that 8 information, we know that this would be 8 over 2 times root 3, or 4 root 3, which indicates that x is equal to 4 and y is equal to 3. And xy plus x plus y is 12 plus 7, or 19. Moving right along to number 12. It states that there are x order 6 poles of positive integers such that all of them are multiples of 4. And they're positive integers, meaning they cannot be 0. And if we divide both sides by, let's say, 4, so that a divided by 4 plus b divided by 4 plus c divided by 4, d divided by 4 plus e divided by 4 plus f divided by 4 is equal to 1956 divided by 4. Or we can calculate that out, because that must be a multiple of 4 unless the question is 0. So our answer would be like 4, 4, 16, that's 35, 4, 8, 32, and that would leave it a 9, 489. And using that one-to-one correspondence, that we know that for every value of a over 4, we have a single unique value for a. So we can just find the number of six poles that are like this: a over 4, b over 4, c over 4, all the way to 5 or f over 4. That would be equal to the number of six poles of a, b, c, d, e, f. So let's get started by calculating that. We know that every one of them are positive integers, meaning they cannot be 0, and there are, using the principle of stars and bars, there are 489 stars, and we want to use 3 bars to separate them to make so that each portion presents a 1 letter over 4, or not 3 bars, my bad, that's 5 bars. So each portion indicates that over 4. It is ordered pair, so we don't have to divide by 6 factorial at the end. So the total amount would just simply be 488 choose 5, because we need 5 bars to separate 6 elements. So that will be 488 times 487 times 486 times 485 times 484 over 5 factorial. And realize that this must be an integer. So 684 484 is a multiple of 11, and there's no multiple of 11 in the divisor. Therefore, this expression must be 0 mod 11. That's our answer A. Let's proceed with number 13. In number 13, it states that an equilateral triangle actually should be ABC here, because there's ABC occurrence afterwards, and let the points on here. So we can draw a vague picture right now with equilateral triangle. It's not the best, but you can just ignore it. And we know there is a formula for the area for equilateral triangle, or root 3 over 4 s squared is equal to the area, or 16 root 3. Divide that out, we can get that s squared is 64. Since the side length cannot be negative, so s must be 3 or 8. So we know that the side length would be 8. This formula actually can be derived with 30, 60, 90 right triangles, because that this will be 60 degrees, and if you set this as half s, that would be half 3 over 2s, and the area would be s over 2 times root 3 over 2s over 2, which is this formula. So let's get started by doing the last procedures that it told us. The last procedures are ax to xb would be 3 to 1. The by to yc would be 3 to 1. And az to zc would be 1 to 3. And we want to find the area of the inner triangle, or perimeter of the inner triangle. We basically want to know the side length, right? So we know that this is 60 degrees. We can solve the problem two ways. So let's mark it more vigorously, because that is actually not 1 or 3, that is actually 2 and 6, since the side length is 8, right? So the first approach I am going to take would be coordinate geometry. Set point B as 0, 0, we can get that C is 8, 0, and Y is 6, 0. And A would be, that would be 4 and 4 root 3. So A's coordinate would be 4 root 3. And dividing that by 4, that would be get us the x coordinate, or 1 root 3. Because that would be 1 root 3, 2 root 3, 3 root 3, and 4 root 3. So we can get the distance from xy to be xy is equal to that distance formula, 6 minus 1 squared plus root 3 squared, all square rooted. That would be 25 plus 3, or 28, square root 28. And we can get that out as 2 square root 7, and the perimeter. So let's say we don't know that inner triangle is equilateral. We can say that this, and this are congruent because of SAS. Think about this. If we have this angle all congruent because they're equilateral, and these sides are all congruent, we can prove that these three little triangles outside of the triangle that we want to calculate would be congruent. Therefore, these three sides would be congruent. So that's an equilateral triangle. Therefore, the perimeter would be 2 root 7 times 3, or 6 root 7, giving us the answer choice B. There's also another approach on this problem on calculating xy. We can also use the law of cosines. I know that is not actually a knowledge point for AMC 10, but we can do it if you know trigonometry well. So it is the length xy can also be expressed as 2 squared plus 6 squared minus 2 times 6 times 2 cosine 60 degrees. We know that cosine 60 degrees is 1/2, so that will be equal to 4 plus 36, oh, xy squared, my bad, minus that would be 20, that and that would cancel out, so that would be 12, and that xy squared would be 40 minus 12, which is 28, and xy would be 2 root 7, which is exactly this, and we can go to this step thereafter, giving us the answer choice B as well. Let's continue with number 14. Number 14, it says 2579 is expressed in base B, and the resulting number would be that, and that both B and N are integers. So we can express this because 5 and 5 in base B would be just equal to 5b squared plus bn plus 5, which is equal to 2579. And that is 2574. It's equal to 5b plus n times b. So we know that b must be divisible by 2574. So we can factor that number. 2574, which is equal to 2, definitely, because it ends with a 4, so that would be 2 times 1, 2, and that's 17 or 8. That would be 1, 2, 7, 8. That would be 2 times, that sum would be 3, 11, 18. So 2 times 3 times 4, 2, that would be 9. So 429 times 3 would be 1287. And 2 times 3. Let's see what can 249 be divided with. So 2, no. 3, yes. We can take a look at that. And it can be divided by 3, resulting in 143. And we clearly know that 143 is equal to 11 times 13. And since 243 is equal to 11 times 13, we can make up some possible values for b. So some possible values for b would be 2. No, because this is a 3-digit number starting with 5, so b is definitely larger than 10. So let's make some up. Like 11, maybe. 13, maybe. It may be 18, right? 2 times 3 squared. It may be 22. It may be, let's say, 26. It may be other ones like 39, 33, 33, 39. I believe I also missed some of them, such as like some of the good ones, because I think that is all of them below 40, because if I use all of those, that would result in 18. If I use 2 of those times 1 of those, then it would be larger than 40. If I use 2 of those and none of these, that would be less than 10. And if I use 1 of these and 1 of these, that will result in the other numbers. So we can test it out in the middle ones. Our goal here is to let 5b plus n to be an integer, right? So if b is 11, then 5b plus n, let's write it in another color. 5b plus n would be equal to 2 times 3 squared times 13. So it's 18 times 13, which n is a digit, remember, less than the b value. So 18 times 13 definitely wouldn't work. 5b plus n in that 13 case would equal to 198, which plus 5b is still too large. And in this case, it will be 143 subtracted by that 5b would give us that 90 plus n would be equal to 143 and it's still too large. And if I say that 5b is 110 plus n is equal to that 9 times 13, or that is 117, so we can get n is equal to 7. If b is 26, then we can get that 26 times 5, or 130, plus n is equal to that 99, which n is a negative number, which does not exist. So n must be 7 and b must be 22. So it asks b plus n, so our answer would be C, 29. In number 15, it says a frog wants to jump from here to here. It can only move one unit in the positive x or y direction, and asks the number of ways he can accomplish this. You can draw a rough diagram down here. I wouldn't draw it very accurately over here, but that is enough for our experience. And so we're given that if this is negative 3, 4, so this would be negative 2, negative 1, and that would be 0, 4. I want to go up to 0, 10, so that would be 5, 6, 7, 8, 9, and there's one more line over here that is 0, 10. So we know that the number of ways you can go to negative 3, 4 will be just 1, because he's just standing there. He's just one way of going there. And the number of ways going this point would be still 1, because the only way would be from the left to right. And in order, the horizontal ones will be 1. And also this one. So for this point, however, there are 2 ways of accomplishing this. It can be from this point and go here, or this point and go here. So the number of ways to accomplish this would be 1 plus 1, or 2. Number of ways to accomplish this would be 3, and that would be 4, and it will be the same here. We can draw the rest, 6, 10, because each can go from this point to here, or this point to here. That's 10, that's 20, that is 15, that is 35, that is 21, that is 28, that is 56, and sum that up would give us the answer 84, or E. And there's also a very, very easy solution to this problem as well. We realize that the frog wants to go right 1, 2, 3 times, and wants to go up 1, 2, 3, 4, 5, 6 times. Therefore, in the 9 steps he has to take to go to 0, 10, there are 3 steps that he's going to the right. So the total number of ways would just be 9 choose 3, or 9 times 8 times 7 over 3 times 2 times 1, or that's 12 times 7, or 84. For number 16, it is a pretty straightforward conic sections test. It gives us 2 conic sections, and we want to find the area between them. We can find 1 of the area and then 2 of the area, and use the principle of inclusion and exclusion, which also applies in coordinate geometry. So let's graph it out first. First of all, there is a circle with radius 2, or the radius squared to be 4. So let's draw it as accurately as possible here. So that's our circle with radius 2. That's our x-axis. That's our y-axis. And the second shape, which is an ellipse. And this shape is actually an ellipse with a longer section like this. I cannot draw it very well here, but here's the deal, that it also has a center at 0, 0, or the origin, and this length would be 3. and this length would be 2. The area of the ellipse the area of the first shape would be 2 times 3 times pi, or 6 pi, and the area of the second shape is 2 squared pi, or pi r squared, or 4 pi. So because the ellipse fully contains the circle, so the area in between would be 6 pi minus 4 pi, or 2 pi. Pretty straightforward question. In number 17, we actually want to factor 21 factorial first. So 21 factorial, we factor it right here. It has to be 2 times 3 times 5. I'm leaving the powers behind now. I will just fill in the powers after. Times 7 times 11 times 13 times 17 times 19. And the 21 over 2 gives 10. 10 over 2 gives 5. 5 over 2 gives 2. And 2 over 2 just gives 1. So in total there will be 2 to the 18th power. And for 3, we have 21 over 3, or 7. 21 or 7 over 3, or 2, and there's nothing afterwards. And for 5, we had 21 over 5, which is 4, and there's nothing afterwards. So that would be 3 to the 9th power and 5 to the 4th power. And 21 over 7 would yield us 3. So that's 7 to the 3rd power. 21 over 11 would yield us just simply 1. So anything after that would be just the first power. So let's erase our draft here so that we can continue working on the problem. Let's calculate the total amount of factors it has. The total amount of factors, because you can choose 0 choose, 1 choose, all the way to 18 choose to form different factors. So there's 19 ways to choose it, thus 19 factors. That's 19 times 10 times 5 times 4 times 2 times 2 times 2 times 2. Let's see our question. It asks the number of positive divisors, that is a power of 6. So a power of 6, let's say it's not something to the 6th power. Instead, it is a power of 6. Therefore, it would be 2 times 3 to the nth power. Although there's 2 to the 18th power in 21 factorial, but there's only 2 to the 9th power to 20 in 21 factorial. Therefore, the only possible values for n would be n from 0 all the way to 9, thus giving us 10. So our numerator would be 10. And we can cancel these out with each other. So our numerator just would be 1. That will be 19 times 10 times 4 times 8. And calculating that out, we can get 32 times 19, or just add a 0, so it's 10. So 32 times 19 would be, that's 9, that's 18, that's 27, 28, 32, 8. That is 608. So that's 6080, 1 over 60080. Thus, x plus y would be simply c, 6081. For number 18, we definitely cannot solve it directly. It is a quartic and very, very messy coefficient polynomial. But we realize that there is some commons between the symmetrical terms. So we can use the idea of symmetrical polynomial and solve this problem. Because we want to find the root of the polynomial, we can just disregard the fx and set it to 0. Therefore, we can write down the equation as x to the 4th minus 14x cubed plus 47x squared plus 14x minus 15 is equal to 0. And adding 16 to both sides to make it symmetrical, we can get that this whole expression plus 1 is equal to 16. And now that the coefficients are officially symmetrical, we can divide both sides by x squared. So that would convert to x squared minus 14x plus 47 plus 14 over x plus 1 over x squared is equal to 16 over x squared. We can rewrite 16 over x squared to be 4 over x squared. And that can be using the exchange method that I went over several videos ago. You can exchange y to be x minus 1 over x, so that y squared will be x minus 1 over x squared minus 2. Actually, will be that y squared would be that squared, which is x squared minus 2 plus x squared over 1 over x squared. And that can be converted into x squared plus 2 is equal to x squared plus 1 over x squared. And therefore, according to, let's plug it back in. And plugging it back in, we can get that x squared plus the x 1 over x squared can be substituted by y squared plus 2 minus that 14y plus 47 is equal to 4 over x squared. And that would be y squared minus 7y plus 49 is equal to 4 over x squared. And convert that, no, actually, my bad, that is actually 14y. And that can be converted into a perfect square, or y minus 7 squared is equal to that. Now we can plug that back in. Now realize that both sides are square, so we have two possible solutions. One possible solution would be y minus 7 is equal to 4 over x, or y minus 7 is equal to negative 4 over x. Let's bust out this solution first. In this solution, we can plug back y. Y is equal to x minus 1 over x minus 7 is equal to 4 over x. And that can be converted to x minus 5 over x minus 7 is equal to 0. And that x squared minus 5 minus 7x would be 0. And x squared minus 7x minus 5 would be 0. And just bash it out, we can get that negative 7, so x is equal to negative b plus or minus b squared minus 4ac, which is 20 over 2, which is 7 plus or minus square root of 69 over 2. And I believe most of us know that is not a perfect, does not have a perfect square factor. So our answer would be 2a plus b plus c. So we want the largest root, so that would be 2 times 7 plus 69 plus 2, or 14 plus 71, or 85. That is one of our answer choices. So let's keep that answer choice and let's bust out the other solution. Other solution can be x minus 1 over x minus 7 is equal to negative 4 over x. And that would convert to x plus 3 over x minus 7 is 0. And multiply by x on both sides. Since x is not 0, get that equation, and x squared minus 7x plus 3 is equal to 0. The only difference is the constant term, and if we write out the quadratic formula, that will be basically similar to the original one, except that it is going to be minus 9. Clearly, you can see that this solution would be, oh, that's not minus 9, that's 4ac. That should be minus 12. That's even smaller. So this solution would be larger. So our answer for this problem would be E, 85. Number 19 is actually a pretty bashy problem. And in this problem, we want to calculate these separate values before we want to calculate the final value. So we want to calculate x squared plus y squared. We want to calculate x fourth plus y fourth. We want to calculate x6 plus y6. We want to calculate x cubed, y cubed. That's not plus anymore, so we can just calculate this as -1. And minus 3xy. Minus 3xy would be a positive 3. And this we can solve by simply using the perfect square formula. That is this, which is 2 squared, or 4 plus 2, which is 6. And that would be x squared plus y squared squared minus 2x squared y squared, which is 6 squared minus 2, because this is positive this time, and that's 34. And to solve for x sixth plus y sixth, we first need x cubed plus y cubed. Notice that these are different. Do not use this value for this, because that is going to cost you the entire problem. And x cubed plus y cubed would just be x plus y times x squared minus xy plus y squared, or x plus y would be 2 times, that would be 6 minus xy would be plus 1, or 14. And x sixth plus y sixth would simply be x cubed plus y cubed squared minus 2xy cubed. Or this also can be written as 2x cubed y cubed. That is the original format, as a is equal to x cubed. And that would equal to 14 squared minus 2 times, that is -1, because 3 is an odd power. So that's plus 2, and that is 196 plus 2, or 198. And that is all we want before we want to calculate the final expression. The final expression would be 6 times 34 times 198 all over -1 plus 3. That would just be 2. So that can cancel out with each other and result in 3. This is a pretty bashy expression, but we can simplify this as far as possible before we actually have to calculate it. So that's 3, 4, that's 12, 102, that's not so bad, times 198. So there is 2 approaches you can take over here. Oh, there's no over 2 anymore because they've canceled out. So one of the approaches to make either 102 minus 2 turn it into 100, or 198 plus 2 turn it into 200. The other approach, because they add up to 300, they can change it to 150 squared minus 2 squared using the difference of squares. No, that is not 150 squared minus 2 squared. So that will be 150 minus 48 times 150 plus 48, and then calculate it out. But I am going to use the other method on this. So that will be 100 times 198 plus 2 times 198. That will equal to 198.00, plus that will be 400 minus 4, which is 396, or 201 and 96 at the end, which is our answer B. This problem, on the first glance, seems pretty simple to me because it can just be simplified using binomial theorem and do that. But that is not all of its story. It uses much more knowledge of that, other than that. And since it is asking the remainder when divided by 1,000, we just want to know the last 3 digits, or mod 1,000. We can turn 11 into 10 plus 1, as I explained before, and use the expansion of binomial theorem. So 1 is equal to 10 plus 1 to the 0th. That's boring, right? 11 is equal to 10 plus 1 to the first power, and 11 squared would be 10 plus 1 squared, so on so forth. And we can simplify the original equation like this into 1 plus 10 plus 1 plus 100 plus 2 choose 1 times 10 plus 1 plus 1,000 plus 3 choose 1 times 100 plus 3 choose 2 times 10 plus 1 plus ... And taking the mod of 1,000, we can get 1. There's 1,010 terms of that, so times 1,010 plus, for 10 it is basically times 1 choose 0 plus 2 choose 1 plus 3 choose 2 plus 4 choose 3, etc. And for 100 would be times 1 times 2 plus 2 times 3, or don't skip that part for now. Let's say that is actually the sum of 2 choose 0, 3 choose 1, plus all the way to 1,009 chooses 1,007. And that is mod 1,000. And we can simplify the first term to be just simply 10. The second term, using the arithmetic sequence sum, we can get that the second term is 10 times the 1 plus 2 plus all the way to 1,009 would give us 450 at the end. And the third term, be careful here, that is actually sum of all triangular numbers. That is 1 times 2 plus 2 times 3 plus all the way to 1,008 times 1,009, but don't forget to divide by 2. So each of these numbers divided by 2 would be a triangular number. And that in itself is very valuable to us. And since we already know the first two numbers, we just need to know it has a 100 coefficient in front, so we just need to know the unit digit of this giant expansion. And there is a formula for that for triangular numbers, because all the triangular numbers are first x triangular numbers, triangular numbers sum would be equal to x times x plus 1 times x plus 2 all over 6. And that means our x would be 108, because it starts with 1 and then with 1,008. Therefore, it would be 1008 times 1009 times 1010 all over 2. And simplifying that, we can get that it is actually 0. So 0 mod 1000. So 10 plus 450 plus 0 mod 1000. So that would be 460 mod 1000, or our answer choice C. As we step into the last 5 problems, the difficulty will significantly increase. So number 21, the difficulty is okay, and most importantly in this problem we're going to utilize Vieta's formula. So let's write out everything that Vieta's formula, but maybe not everything, but most of the things that Vieta's formula tells us in a cubic function. First of all, r plus s plus t, or the sum of the roots, would be 2, because that would be negative b over a. And rs plus st plus rt is equal to 4. rst would be equal to 8. Examine the expression that it wants us below. So let's think about this expression. How can we format this so that this uses these 3 expressions? So let's see. That's as r, that's rt squared, that's ts squared. So maybe we'll try to pull out a common factor of rst, because we know rst is equal to 8. So we can simplify this expression to rst times r over s plus r over t plus s over r plus s over t plus t over s plus t over r. So that is all of that's the original expression. And this value can be simplified into, this value inside can be simplified into r plus s plus t times something, as we realize that you can combine these terms. So we don't want to do it one step so that you don't understand. I will try to do it as clear as possible. So let's combine the terms with the common denominator. So that would be equal to s plus t over r plus r plus t over s plus that r plus s over t. So examine this carefully. What do we notice here? First of all, we can add a 1 to every single term in it. Therefore, we can try to make it like this. So add 1. S plus t plus r over r minus 1 plus r plus t plus s over s minus 1, because r over r, s over s, and t over t are 1s. So plus r plus t plus s over t minus 1. And that expression, we don't forget the RST in the front, we can take out this. So that would be s plus t plus r times, that would be the minus 3 at the end, do not forget. That would be times 1 over r plus 1 over s plus 1 over t. So that is our expression. And how do we calculate that? Vieta's formula comes in handy. And r plus s plus t can actually be simplified further. So r s t times s plus t plus r times, if we put that into one fraction, that would be rst rst under so rst plus TR plus TS over RST minus 3. And we know all of the expressions here, so let's put the values in. RST, that would be 8. S plus T plus R would be 2 times RST, that's 8. ST plus TR plus TS, that would be 4 minus 3. So that would be 8 times 12, or 2 times 1/2, which is 1 minus 3. That will be 8 times -2, or -16. However, it is asking the absolute value of it, so our answer would be D, 16. In number 22, it asks what this expression divided by 16 would be. So this expression divided by 16, as we can see, each of the expression is 10,000 plus 1 to something's power. And 16, when we use the divisibility of 16, we just need to know the last 4 digits of it. So let's take mod, last 4 digits, which would be 10,000, mod 10,000. And clearly we need to use the binomial theorem here as well, because that is 1 over just a whole number, and it's actually the number that we want to mod for. That would be very useful. So let's disassemble 10,001 to be 10,000 plus 1, and that to the 111th power would be that. So that would be 1 plus 10,000. That would be 10,000 choose 1 times 10,000 to 1 power times 1 to the 110th power. And that would just cancel out when I mod it by 10,000. So anything after that would be canceled out. So that, actually all of these, so that would just be 1 mod 10,000. And notice that the other powers are actually, say, 10,001 to the 222 second power would be equal to 10,001 to 111th power squared, because that multiply is equal to 222. Therefore, each of the other terms after would just be 1 mod 10,000, since 1 to the any power would be 1. And then that brings us to the next point. So that would be 1 plus 1 plus 1 plus all the way 1 plus 99, 90 mod 10,000 is equal to something mod 10,000, and that's 10 ones. And that would be 10 plus 9990 mod 10,000. Although we really don't need 10 mod 10,000 here, but that would be 10,000 mod 10,000, or 0 mod 10,000. And that also shows us that this expression is divisible by 16. So our answer would be A, 0. In number 23, it has a very, very long-looking problem, but it is not that complicated. Basically, there is a regular octagon with side length 8, and by the way, this label for this diagram is a little bit misplaced, because it actually says B, G, C, F, A, D, and E, H. However, in the diagram, it will be A, F, E, B, E, C, H, and D, G. But that does not impact the problem. I mean, it does impact a little bit, but it doesn't impact a whole lot. So the idea is that there is 4 diagonals and there's a square in the middle. And we want to find the area that the unit square can locate where at least half of the unit square is in the middle giant square. So basically, let's think of the center of the unit square. Where can the center of the unit square land in order for at least half of the unit square to land inside the giant square? So we know that this point can happen because that's at least half. But anything above that, because there's a part of unit square going out, that wouldn't be half. So this distance would be 1/2. All the way to this side would be 1/2. And now, there is another condition where it says it has that, but it must intersect or touch the side of giant square. So the unit square cannot be too far away from the side. Therefore, there is a 1/2 as well on this side, where the unit square center just exactly touches the edge of the square. If you go in anymore, it wouldn't touch anymore. And because that square is symmetrical, so all four sides would have the same shape. Let's just draw it out now. So the shaded area is the area that we want to calculate. So because that has a side length of 8, therefore this side length would have exactly 7, because each side there's 1/2 cut it out. And there are 4 of them with width 1/2, so the area would be 7 times 1/2 times 4, which is 14. Now, we want to find the area of the region, so that would just be 14. Number 24 is a confusing question as well, but this is not very hard if you actually understand the problem. So it gives us the equation. Let's try to draw it out over here with x center is at 2√2, y center is at negative 2√2, and there is a radius of 2√2. So it would be like this over here. And let's put our information. So that's 2√2, that's 2√2. Our center is over here. And the two axes, x and y, on the standard Cartesian plane, which is just a standard xy plane, intersects the equation. So this equation, notice that is that equation, not everything inside it. So at a and b respectively also align with slope -1, both intersects the equation at a. So let's see. And the two axes, x and y, intersects at a and b. So x intersects at a, we know the coordinate of a. Y intersects b, we know the coordinate of b. Also align with slope -1, both intersect the equation at a and at y-axis at c. So we can calculate the coordinate for c as well if we do want to do that. And that point is c. And another line with slope -1 with both intersects the equation at b and intersects the x-axis at point D. So let's try to draw that out as well. They're parallel, notice, because both of their slopes are -1. So that's point D. And now, given that -2√2, 2√2 is point E, and that is actually a right angle because this point is actually 0, 2√2, and this one is -2√2, 0. And the enclosed area of the curve AB and line segments curved AB and line segments BD DC, or BDDE, EC, and AC can be expressed as that. I want to find 2x plus y minus z. So now we can clearly see that this problem can be used using this circle. So we can calculate this left upper area easily, because that would be 2 root 2 squared. That would be 8. And this area can be calculated easily as well, because these two are equal and these two are 45, 45, 90 triangles. And that will be 2 root 2 times 2 root 2 divided by 2, as they're triangles, but multiplied by 2. So these cancel out. That area will be 8 as well. So the most tricky area would be this area. And this area can be easily solved using this rectangle. We've calculated the area of this square to be 8, because this is congruent to this one. So that will be 8. And this quarter circle with radius 2 root 2 can be calculated easily as well, with 1/4 pi r squared. R would just be 2 root 2, so pi times 8. And that will result in 2 pi. Therefore, this blue shaded area would be equal to 8 minus 2 pi. Thus, our answer would be 8 plus 8 plus 8 minus 2 pi, or 24 minus 2 pi, and getting that out would be 2 times 12 minus pi. And don't panic if you see that it is pi, not z pi, because z can be just 1. So x is equal to 2, y is equal to 12, and z is equal to 1. And 2x plus y minus z would be 4 plus 12 minus 1, or 15. So our answer would be E15. In number 25, this problem is actually the one that most people didn't answer on our mock contest. And this problem, only one of our participants actually answered correctly. So let's see what this would be. And that participant also shared the solution with us. So I will share the solution with you guys right now. And in this solution, he basically uses casework to narrow down the number. Now, I will credit his solution here. It is created by Jupiter 314 on Art of Problem Solving. And I'm sharing this solution with you guys because this may be more easily understood by you guys. And let's get started. In this problem, we notice that the first 3 digits are especially important, and the third digit must be rather small for it to have. So the third digit can be 1, and the common ratio would be 2. Could be 2, so that would be 1, 2, 4, and it can have a going up. So it can start with 5 to 1 as well, because 2500 times 2 can be starting with 5. So that is all done and dandy for once. No, actually for 1 and common ratio as 2. It can also be 1, 3, 9 as our common, as 3 as our common ratio. So let's just write it down. Common ratio 2, common ratio 2, common ratio 3. And next, we can have starting with 2. like such as 2, 4, 8, like that. There is another possibility with 2 where it can be 2, 4, 9. And both of these cases have common ratio 2. And that should be all of the first 3 digits there can be. And from here, we can try to figure out the next set of digits. So ABCD cannot be from this set because you will realize that 421, if it starts with 421, let's say 1, then multiply by 2, it would not work. And the only thing that may work, notice that may work, because 421, that's a 2, and so this number must be 4210 or 41 something. This number must be divisible by 4. And 10 wouldn't work. 12 may work. 16 may work. And 20, that's 2 and 6 are 2 of the answers for this case. So, notice that if we want to divide this by 2, we will get 2, 1, that's fine, 2106, but that's 1, so that doesn't work. If we want to have it 4216, and that divided by 2 would be 2108, that wouldn't work either. And the next case would be 521. For 521 to work, yes, it has to be a multiple of 4 as well. For it to be a multiple of 4, let's say it can be 5212 or 5216. If it is 5212, then divided by 2, that's 26 something. That's nowhere near what we want. And 5216 divided by 2 would be 26 something as well. So that's not what we want either. And having 931, we notice that this number must be divisible by 9. And 93, that's 12, that's 13. And having 13, if we want it to divisible by 9, that has to be 5. And divided by 3 first, we get 3, 1, see that? And 0, 5. And that is not what we have here. And we have 8, 4, 2 something that has to be divisible by 2 as well. And what we have here, divisible by 4, we have 20, 24, 28. And 8420 divided by 2 would be 4210. But we don't have that because this number would be 1 instead of 0. And 8424 would give us 4212. 42.4, we are left stuck here as well. And if we have 8428, then we have 4214. That would not work either. And for our last case, it has to be divisible by 4 as well. So that will be 0, 4, 8, 3 possibilities. And that 9420 would give us, let's divide it out. So 9 would give us 4, 4 would give us 7, that's 4, 7, 10, that's nowhere near what we want, as we want 2 for our second digit. And 9424 would just be adding 2 to upon our solution. So 47, 12, 47, 14. And that are nowhere near our solution. and that is all possibilities get rid of. So our answer will just be 0. Thank you for watching and have a great day. Note that please comment all of your questions down in the comment section so that I can answer them